The development of the EOG measurement device, we first started by developing a prototype on a breadboard. As you can see here, we have the input side of we had our voltage regulators to get our 12 volt virtual ground and 0 volts. Then we essentially had a VCC supply of 10 volts with the virtual ground being at 5 volt. Each stage we have the instrumentation amplifier, which goes onto the 50 Hz notch filter, which then passes through low pass filters, and then the signal gets rebiased between 0 and 5 volts with a voltage divider here to bias the small signal at 2.5 volts. After we developed our prototype, we then went on to build our first iteration PCB. If that would focus. Yep. So the first PCB was good because it was compact, everything was solid, nicely put together, maybe a bit of dodgy soldering here and there, but it was very effective. We then decided to go on to develop a second PCB which had additional jumper inputs, so it made swapping out the resistor to change the gain of the instrumentation amplifier easier. We also had more inputs for the supply voltage and the EOG inputs from the electrodes and a virtual ground input. We also had down the bottom additional jumpers for output and virtual ground. To be a bit more explicit with the EOG measurement device, you can see here the first stage, just highlighted here, is the amplifier stage. This is the instrumentation amplifier. Then we got the 50 Hz notch filter, then the low pass filters, then the bias, which biases the signal down to between 0 to 5 volts for the microcontroller input.
And now we're going to go over the prototype for the IR stage of the EOG media controller. As you can see here, we've got the 4 buttons. They correspond to left, right, down and up. And this one over here sets it to configuration mode. These 4 LEDs show which way the user is looking or which button is pressed down. This one here shows whether it's in configuration mode if that button's pressed, and this one shows whether it's locked, and if it is locked the buttons won't work. You can see here we've got the IR LED for transmitting IR to your TV or your stereo or anything like that. Down here you've got your receiver so that you can receive the signals and store them to the Arduino, and over here we've got a potentiometer for testing the ADC input with the Arduino. After we got this working, that's when we hooked it up to the amplifier and the filter circuit to get it to work with the actual electrodes so that eyes could control the board. And that's basically it. And we'll go on now to show the electrodes working for picking up signals and how the final circuit actually works. So we have looking left, right, and repeatedly looking left and right. Hi guys, I'm here to do the demo for the EOG media controller prototype. To set it up we need to put it into configuration mode and then map the buttons across from our remote. So now we're mapping across the next button, the previous button, and the play button. And as you can see, it started playing because it's picked up on the IR from the remote. So I just took it off config mode and we should be ready to go. Now I can look around, look left, right, anywhere, and it won't actually start working until I've taken it off lock mode. And to do that, I need to look right for a few seconds so that it gets out of that state before I can actually take control. So let's try that now. Okay, so it should be off lock mode. Now let's try playing it by looking left for a few seconds. There it is. So to change track, I'll just look right quickly. don't really want this song, so I'll skip again. Oh, I don't feel like that one. I think I might want to go back. That's the one. So say I want to pause it again, I just look left for a few seconds. There we go, but I did want to play that song, so I'll play it again. And then I want to lock it so that I can look around. Okay, so let's look around, not doing anything. All good, and that's the demo. Thanks for watching.